Okay, welcome back to episode 12 of How to Leet Code series. Today we're going to be solving LeetCode 160, intersection of two linked lists. And I wanted to quickly say that this problem is, we're just going to keep doing the linked list problems because we're trying to get better and better, right? So this one is rated an easy problem, but I would rate this probably like medium to like, yeah, I'd rate this a medium to maybe even like a medium hard, just because like there's a bunch of ways to solve it, but the most efficient solution comes not really that intuitively. Sorry, I can't speak. But anyways, let's read the problem statement together. So given the head of two singly linked lists, head A and head B, we want to return the node at which the intersection happens. So this is a little bit tricky because, as you can see, this first example, the first linked list, there's definitely an intersection we can see, but the length of the linked list, however, is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5, 6, right? So if we you might have an intuition maybe to use some slow and fast pointer shenanigans, but that might not work because if we keep incrementing this by one and then by one, this one will never catch up, so we won't really know whether they intersect. So the main problem that we're trying to tackle is that we know that there could just be a case where these are separate. So imagine that this is not here and this just ends, right? So B3 will point to none instead of C1. And in that case, we would just return null, meaning that they don't have an intersection at all, right? So I'm gonna go ahead and snip this real quick and tackle the problem that way in Paint. So let's see this example right here, right? So get my drawing out. So another way that we can this this problem has a little bit of caveats because we want to be able to solve this in O of one time without needing extra space. But before we do that, I will show you when I saw this problem for the first time how I approached it, just because in the case that they're saying if the follow-up asks could you write a solution that runs O of n plus n, right, time where m and n are the length of each linked list respectively, we can assume that there is a way to solve it with a set. So one of the ways that we can do it, if we go back to Paint, is we'll just keep track of the. We'll have like a visited set, right? So we'll just keep track of this, right? So the first thing we can do is iterate through this first list. Let's say we're gonna start with A, right? So we keep track of. Let me make this a little bit nicer. So let's say this is our set. Give us some space here. We add a one. We traverse to here, right? Um, what was that? Not sure what that was in the background, but probably my cat. Uh, A1. Then we're gonna traverse A2, so we're gonna add A2 to our set. Then so on, C1, C2, C3, C4. Luna wants to say hi to the camera. Hey, Luna. But anyways, uh, where were we? C2, right? C2, C3. And this is very useful because, as we've seen in a lot of linked list problems, um, this will eventually point to null, right? So we know that these two sets are going to excuse me, increment eventually and meet either here or uh, in this test case, it's going to meet at C1. So with that being said, now we're at C3 and we have all these in the set, right? So we know that we have these objects in memory. Uh, they're gonna be kept tracked for us. So now we can start to increment. Let's use a different color. Let's use green. We'll start from here. Have our pointer shift here. 2, 3. So we'll increment at B1, then B2 to the set, then B3, when we eventually increment this, now this is another loop, so this would take two while loops. Um, we're gonna eventually find that we seen every check we're doing is we're gonna have a conditional statement where it's saying, have we seen this node before? So yes, we've seen C1. C1 is actually in our set. It's right here, right? So we see C1, and then let me use a different color, maybe light blue. Yeah, so when we see C1, we can check, oh, wait, C1 is in the set. We can go ahead and return immediately. So this is the drawing solution for the first example of the set. So this is how I solved it when I first looked at the problem. Let's get right into the coding. Hash set is equal to set. So we're gonna set our pointer, let's call it P1 equal to head A. And while head A, or while P1, while there's still a node, while there is a valid node, what we want to do is add everyone to our set. So while P1, how do we add that? Hash set dot add P1 to our set, and then we're going to want to hash set dot add, and then P1 is equal to P1.next. So now that we have, we're at the point where, get rid of this. We're at the first part, so we're in this section. We've added all of these values to the list. So A1, A2, blah blah blah. Sure. So now we'll make another pointer to traverse our second linked list, which is P2. While P2, we start iterating. If P2 is in our hash set, we can go ahead and just return P2. Otherwise, so if we see this node, the first node we see that matches, we know that it's the start of the cycle. Otherwise, what we're gonna want to do is do the same thing. So we're gonna hash set dot add P2, and then P2 is equal to P2.next. We want to traverse the next node, and this test case again says return null, right? So it should be good. Syntax error, don't forget that, and then boom. This is a pretty good submission. This is this is like how I would have solved it. But if you've watched LeetCode's video, he does go ahead and explain like the math behind it. So I'll go ahead and explain that. We can just remove all of this for now. I actually did not want to remove that. Yeah. So we have our example again. Now that we've solved using the hash set solution, we want to see if we can do better. So essentially, we're gonna leverage the length of these lists. So again, 3, 4, 5. This points to null, right? That's our end of the linked list. 1, 2. Well, this is a problem, right? Because essentially, this is never gonna match if we just increment this by 1. So somehow we need to leverage the distance, right? So the trick actually is, I'll just go ahead. Yes. I'll just go ahead and say it for you guys out loud. The trick is to find the difference between, by iterating from, let's say we start at this node, right? We're gonna do 1, 2, 3, 4, 5 at this first list, and then we're gonna start iterating through this entire list. So it's gonna be 7, 8, 9, 10, 11, 12, right? But keep in mind that this is 0 and next. But the whole trick is that we're essentially getting to the point where if we know the length of the linked list, right, we can do the same. So we're gonna go through this first. 1, 2, 3, 4, 5. When we get to the end, we're gonna set that equal to this node. So 6, 7, 8, 9, 10, 11. And we're gonna do the same tactic for list B. So 1, 2, 3, 4, 5. My handwriting's terrible. 6. And then when we get here, 7, we'll do the same thing. And then they both will eventually have length 11, right? So when that pointer gets there, when this pointer gets to, let's start from A again. When we set this to 6, right? Let's say this is going to be happening at the same time. So both traversing the list, we know that they're going to intersect here. So we want to basically shift this B pointer by 1 so that it perfectly matches in line with A1 and B2. And the first intersection that we see is actually going to return that for us. So if that explanation wasn't clear, I can start coding it. The solution starts off with, again, we have head A. Let's just call it P1 and P2 again, respectively. Head A, head B. So while P1 is not equal to P2, what we want to do is set P1 equal to P1 dot next. If P1 is not empty, and else we want to set it to the head of the list, right? So of head B, because again, when we get here, so 1, 2, 3, 4, 5, right? We want to immediately start. Hey, like if it's not none, start at the head of B first, and then keep going, because eventually they will march towards each other. Same for this one. P2 is equal to P2 dot next. If P2, else we want to set it to head A, right? And eventually, we'll see that they'll meet. And if we don't, we could just return P1, or yeah, we could return P1. It doesn't really matter, because again, we're returning at this point. They will have intersected. So yeah, head B is not defined. Capital B. Yeah, so this one works too. And as you can see, the runtime I believe was like 50 milliseconds less latent, but this one is again in O1 space of big O of, that's small o, but big O of n plus m time complexity. So there you go, guys. That is how you solve it. Intersection of two linked lists. I rate this medium problem. Yeah, I'll go ahead and see you guys in the next one. Let me know, give me some feedback for this explanation, because I'm not gonna lie, it was a little tricky to like understand first, because like it's just not something you would think of at the spot. It's one of those, again, where if you've seen it, you know how to apply it, but if you didn't, then good luck. But yep, I'm gonna be churning out a little bit more videos, so I'll see you guys in the next one. Peace.